Welcome to video 2.3c, some concrete applications of expanding binomials with Pascal's triangle. I've got Pascal's triangle up here as a reference. Once again, if you cannot reproduce Pascal's triangle, you're going to get that problem wrong and all the applications. And again, from previous history, most students mess up with the first few rows. So just practice before we have the test. A 1, a 1, 1, and then you can see the 1 plus 1 being 2 and the 1's on the outside. All right, so I did change example B in your notes, so please change it to this. So let's start. A plus B raised to the 4th power. So I want to go to row 4. So just to let you know, this is the row that I'm going to be going to. All right, so the very first coefficient will always be a 1. So I'm going to say 1, and then it's going to be that letter to that highest power, a to the 4. And just to be robotic in the template, I'm going to say the second letter to a 0. That way I can see what's going on. Again, b to the 0 is 1. It's not needed. It's just going to help you be a robot and get this problem correct. Okay, then all I'm going to do is grab the next coefficient, which is a 4, and then this exponent goes down 1, and this exponent goes up 1. So it'll be a to the 3, b to the 1, down and then up. The next coefficient will be a 6. This exponent goes down 1, this exponent goes up 1. A to the 2, b to the 2. Next coefficient is a 4. This exponent goes down 1. This exponent goes up 1. A to the 1, b to the 3. And then the last one is a 1. This exponent goes down 1. A to the 0. That exponent goes up 1. And then I would ask that you clean it up. So that's just the easy robotic method. Now let's clean things up. So I can go a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And the cleaning up will be especially important in this example, so it's a good idea to get in that good habit. Okay, well a plus b to the 5th is going to be very similar to that, except now we're in row 5. I'm going to need some more room, so we'll start below here. I might need to wrap around. So once again, 1a to the 5, b to the 0. First thing, super high. Second thing, super low. Plus, next coefficient is 5. Now I'm on easy street. Go down 1, a4, b1. Then I'm at a 10. Down 1, a3, up 1, b squared. Another 10, plus 10, a2, b3. I'll wrap around. Maybe I'll squeeze it in there. Plus 5, a1, b4. And then I'll squeeze this in at the end, plus 1, b to the 5. All right, let's clean that up. I'll use a different color. So we'll go a to the 5 plus 5a to the 4b plus 10 a3 b squared plus 10 a squared b cubed plus 5a b4 plus b to the 5. Whew. Okay, and then finally, this one, notice, has a number in instead of a variable. So it's got a variable and a letter. So again, I'm just going to do the robotic thing and then clean it up at the end. So it's got a power of a 4. So just to let you know, I'm in row 4. Okay, so again, starting robotic. First thing, super high. So x to the 4th. Second thing to the 0th. And that was a coefficient of 1. All right, plus the next coefficient, 4. And then just this goes down 1, this goes up 1. So x to the 3, 2 to the 1. Next coefficient is a 6. Down 1, up 1. X to the 2, 2 to the 2. Next coefficient is a 4. Down 1, up 1. X to the 1, 2 to the 3. And then my last coefficient's a 1. Down 1, up 1. X to the 0, 2 to the 4. So again, that's just the robotic template. Now cleaning up with the numbers and the letters. So this is just an x to the 4th. Now this is the number 4, and that's the number 2, and 4 times 2 makes 8. This is the number 6, and this is the number 4. 6 times 4 makes 24. This is the number 4. This is the number 8. 4 times 8 makes 32. And then x to the 0 is 1, goes away. 1 times 1 is 1. So 2 to the 4th. 2, 4, 8, 16. And that's how I'm going to want the answer on the test. Whew. So there you have it, how to expand binomials using Pascal's triangle as a shortcut.